Alright, hello and welcome everybody to the quiz one for second marking period, our practice problems. This is just what you should be expecting to see on the quiz. Nothing more, it's going to be just like this. And I wanted to go through this and just have even some extra practice if you wanted. So we have 4 questions here. These first 2 questions is all I'm going to be asking for scholars, and then the final 2 questions, because we went through that with the honors class, that's what I'm going to expect as well. Um, so you must include your unit. I'm going to say that first and foremost. Don't just give me an answer of a number. I need to have your wavelength, right? That should be in meters. Your frequency should be in hertz. Your energy for this one should be in joules. And give me 2 decimal places. The system we're going to be using for our quiz is going to basically ask for that. So 2 decimal places. And I'll put this on the quiz as well. And down here, I will give you formulas. I'll give you constants. It's up to you to know what to actually do with these formulas. You're not just going to get the formula and, you have to know what this formula actually means rather than just, oh, here's some random letters. So I have up here the scientific calculator that I've shown to use that you can use at home for your practice. I do have one of these calculators here as well, and so I'll probably show how to do it as well via my webcam. So, first question, what is the wavelength of a frequency of 7.5 times 10 to the 5th hertz? Well, first we're going to start off with, I'm just going to copy this here, our formula. Now, if C equals lambda times nu, we have the frequency, and we know what C is. C is 3 times 10 to the 8th meters per second. So we have C, and we have nu. We are trying to find lambda. We're trying to find that wavelength. Oh, didn't mean to do that. To get our wavelength, we are then going to isolate the lambda. And simple way to do this, we divide each side by the frequency. This cancels out. C over our frequency equals lambda. So I can actually write this in. So C divided by, do it like this, just because you have these answer key as well. This is that basic level of algebra that you are expected to be able to do for this class. So we're now going to plug in our numbers. We know what C is. We know what nu is. We're going to put in our values. So C is equal to 3.0 times 10 to the 8th divided by 7.5 times 10 to the 5th. Now, I'm going to do this 2 ways. I'm going to do this on the calculator here, and I'm going to do this on the physical calculator. So, first and foremost, we take 3E8. This E8, I'm going to write this here as well. 3E, or on the other calculator, it'll be 3E, capital E. This is equivalent to 3 times 10 to the 8th. These are the same thing. Okay? So 3E8 divided by 7.5 E5 gives us our answer, 400. So the wavelength would be 400 meters. Done and done. I will show you how to do that on this calculator as well here. Alright, I have to do this backwards. This is going to be fun. So 3. To get the E, the second key, all the way up here in the top left corner, and then this key right here. And then we press R8. This is the same thing. So we're going to divide it by, oh, the glare is not, there we go. I'm going to do 7.5. The glare is not my friend right now. Okay. That second key, this one all the way right here, and then this key again. You get that E, and you press 5. Calculator should look something like this. Press enter, you will get the same thing. All right. That's probably the only time I'm going to show how to do that calculation on this calculator, just 'cause it is kind of hard to do both. But the math is going to be the same. So our answer, it's going to be 400 meters. All right, we're going to clear off our pen. What is the frequency of a wave with a wavelength of 6.4 times 10 to the negative 10th meters over lambda? Because we have our lambda equals our frequency. My bad. And this is going to give us, we go down here, 3.0 times 10 to the 8th divided by 6.4 times 10 on negative 10. We're going to put this into our calculator here. 3e8 divided by 6.4e. Now, there is no negative sign on this online calculator. It's a little bit different than our calculator here. I'm going to show us how you would write this just on this calculator. So on this calculator, you're just going to do subtract 10. So this is saying 6.4 times 10 to the negative 10th. Put this in, and this is going to be your frequency. So 4.69 times 10 to the 17th hertz. That is our frequency. On this calculator, and I'm sure somebody's going to make this mistake. When you do 6.4 E, like this right here, where my finger is the negative key. You will need to press the negative key right here at the bottom to get the correct answer. If you press this button here, the subtraction button, you will get a syntax error. So where my finger is, this is the subtraction. Do not use this for a negative number. Use this number for a negative number. So I will say, if you get a syntax error, call me up. Guaranteed 9 times out of 10, that's going to be the error. Okay? There is our answer. So that is all for these scholars. I'm going to move on to the energy questions for honors. All right, so the energy of a photon with a frequency of 7.5 times 10 to the 5th hertz. We have our formula here, and this is probably as straightforward as you'll get. Energy equals our Planck's constant, 10 to the negative 34th, multiplied by 7.5 times 10 to the 5th. That's it. And then this is literally just putting this into the calculator. So 6.626 times 10 to the negative 34th. Again with the negatives. Please don't get a syntax error. I'm going to multiply this by 7.5 times 10 to the 5th. And this is your answer. 4.97 times 10 to the negative 28th joules. This is very, very small amount of energy. This is probably like a really long radio wave, so very low energy. Finally, a photon has an energy of 6.4 times 10 to the negative 14th joules. What is its wavelength? This one's just a little bit more involved. So we have our formula here. We have this formula here. Alright, so we have our two equations here. First thing to do, we have our formula here. We have our frequency in this formula. So let's isolate for the frequency so that we can plug something into that frequency here. We're using our transitive property. So let me show you what I mean. C equals lambda times nu. So let's isolate the nu. Just get the frequency. We divide each side by lambda. C over lambda equals nu. Now, in this formula right here, we are going to put this we're going to substitute this nu for this equation. E equals H times C over lambda. See what I did there? If you're confused with this, like, please come see me at some time. We just converted this. We substituted this nu for this equivalent statement. This is our transitive property. So we now have a formula. E equals H times C over lambda. So I'm actually going to over our lambda. So there's our formula now. We have all of these things. H and C are constants. E is what I give you here. We just are trying to find our lambda, which means we now have to isolate for our lambda. So how are we going to do this? We're going to multiply by lambda on both sides. This cancels out. We now have lambda E equals HC. And now we divide by E on both sides. This E's cancel. So lambda equals HC over E. We've now isolated for lambda with three numbers that we know what they are. Put this here. Lambda equals HC divided by E. Capitalize the lambda. Are you kidding me? Fun fact, this lambda is actually the lowercase lambda. Then we get 6.626 times 10 to the 4 times, I should use the asterisk, times 3.0 10 to the 8th, all of that divided by 6.4 10 to the negative 14th, all of our pen, and we're going to put this into, I should put parentheses around this, just to make things a little bit simpler. I'm going to tidy this up. Alright, so we put all of this in. 6.626 times 10 to the negative 34 times 3.0 times 10 to the 8th. Divide this amount by 6.4 times 10 to the negative 14th. And we get our wavelength equals 3.11 times 10 to the negative 12th meters. So there is our answer. So this is most likely like a gamma ray or something equivalent. Alright, that is all for me. I'm gonna, post this after school on Thursday, just as review if you would like, and you might come back to this for the test.